I thought maybe here it becomes a little bit more interesting for some of the tool vendors. What are we using? For current system, we're using OC system compiler for AIX. Although we upgraded from AIX 3.5 is when we used on DSR and NERC. Then we did use Ada Core technologies to support us when we used GNAT on Sun Solaris. And we still have some of that in the support environment. There's a case study written up for Ada Core, in fact, with we had very specific needs for our middleware, for our infrastructure, and ways of measuring performance and special, not necessarily standardly implemented or standardly available features of the compiler, but we worked with Ada Core, and they implemented some of the features in the annex that we required, and that was a success story for us. We are then using OC Systems compiler for AIX 5.3, which is our current platform, and here and there, we also have geographically distributed vendors who work on the system, and they don't necessarily all use the same tools. The target system, of course, is AIX, and so we use the OC Systems compiler. But for instance, there's a whole group who was working remotely in Canada for a while, Raytheon, but since then has dissolved, it's no longer Raytheon. And they were using IBM Rational Apex environment that we, the rest of us, are not using. And there was a group using Ada Core GNAT, but then they all come together at the factory to get recompiled for the target hardware. Okay, we use ACES extensively. Those of you who go regularly to Ada conferences, you may have heard various papers presented by colleagues, but we use ACES for generation of our adaptation data. We go through a process of what we call tooling, but basically we build a types dictionary from the Ada and ACES, following ACES, and then we use those to generate our adaptation data offline, as well as doing debugging offline, as well, for instance, interpreting recorded data. If we record binary data, then if we have the dictionary that corresponds to that release of the system, then we can interpret that binary data in strongly typed Ada records. Okay. We do use standards checkers, and we do advertise our standards and limit. We don't use Spark, but from the standard Ada 95, we don't allow, by policy and by standards checker, we don't allow all features of the language, only a subset. In the infrastructure, we allow somewhat more, but at the application level, we allow somewhat less. We use memory analysis tools to make sure we don't leak memory and that we fit within budgets. The dynamic analysis tools, we have zero fault for memory leaks. And aprobe, which I have a link to on the next page, but this is basically, you just now heard Franco talk about trace. Aprobe is the tool we use to trace, without the need for instrumentation. So in the prior version of the system, in URET and DSR, you had to instrument your code to use aprobe. In this version of aprobe, there is no need to do that. You can turn on trace, and it generates trace files that shows you the paths of execution in the code, and we use that for either for debugging or to establish during unit testing that we did line coverage. We also use it for doing some performance analysis, so it's widely used. Okay. aprobe, there's a link there in case you want to look into that. Then aprobe exception analysis tool. We definitely like to do exception analysis to see that all the ADA exceptions are stopped or mapped or handled appropriately as close to the spot where the ADA exception was raised as possible, because that's where the preponderance of the evidence or the information about that exception exists. I mentioned that it's not all ADA, so we do have, for instance, the display software. Some of the display software is in C++. And so we have the middleware is in ADA, and we have, therefore, wrappers that allow the C++ application to use our ADA middleware, which brings a challenge of raising an ADA exception and passing the information to the C++ code, and sometimes the other way around, raising or throwing an exception in C++ and passing the information to the ADA infrastructure. And the reason we need that is because it's the ADA infrastructure that decides when to fail an executable and report it up the chain to the monitoring stations, etc. And I think I have an example on that coming up in a page or two. For performance measurements, we have tools that help us capture path length measurements. And then these path lengths can be fed into our performance model to predict before the system is built, because once it's built, we can actually measure. But to predict in advance if we will be able to fit in the appropriate, not just in the whole computer, but with the reserves required, memory and disk and CPU utilizations. So we use for that when we, like right now we're using AIX, so we very much like the AIX trace facility. When we use Solaris, there's obviously not an AIX trace facility, but then we build something similar to that of our own. The Solaris trace facility is not as flexible as the AIX trace facility, because in AIX trace, the user is able to add his own hooks. So if you were to look at all the events that the operating system, all the interrupts that occur, then you would like to see, but where did my events occur in sequence of all of those? And in AIX trace, you are able to call AIX trace facility and provide information, of course it's somewhat terse, that can be inserted into that trace. And it's a lot more helpful for debugging and measuring performance. In Solaris, you can't quite do that, but we got around it and developed our own device driver. This was a surprise to us because if you read most magazines, they claim that there is a huge amount of systems that are developed in C and C++, and therefore we would have expected to find very mature C and C++ tools, but we didn't. Or at least not for high availability real-time systems.